Okay, functions with multiple arguments. Right, we're going to create a new function called gccontent seek. So it doesn't have to be an X, it can be whatever. This is just a variable name I'm using in here. Or a parameter name, I should say, right? That calculates the percentage of G and C bases in a DNA sequence string. Test your function on a few invented sequences. Okay. All right. So I'm gonna be well behaved here. I'm gonna start a new file, and I recommend you do the same, just to keep it separate. Right. So we're gonna create a new function. Let me just write down what we're doing here. Create a function that calculates percentage of G and C bases in a DNA sequence. Now we've done something very similar to this in the assessment, and in the first assessment, I should say, and in a couple of previous exercises. So no surprises, but this time we're going to write a function to do it. All right, so I'm going to create a function def. Right, that means Python knows what's coming. Then I'm going to create a function called gc_content. And I think in the notes I put seek. Okay, it doesn't matter what I call this as long as I'm consistent when I start to use it later. Okay, and what do I want to do? I want to, let's have a think, count the number of G's and C's. Okay, now to make sure I'm only handling, because this is all case sensitive, right? So make sure I'm going to be able to handle both lowercase and uppercase. I'm going to be safe, and I'm going to use the upper function on my seek variable to begin with. That'll just make sure it's all uppercase. Then I'm going to create a new variable within my function called gccount, and I am going to no, I can't remember how we did this previously, but I know that on my variable, if it's a string, I could use a function called count, and I can count the number of characters that are in there, and that will return a value. Okay, so I'm going to count the G's, and I'm going to count the C's in my string, and I'm going to ignore everything else. Okay, then remember I want to return a percentage here of G's and C's, so I'm going to do GC and create a new variable called GC percentage, and I'm going to calculate it. So I'm going to go GC count divided by the length of the sequence. You've seen that one before, and then I'm just going to multiply the whole ratio by 100. Here's the important bit coming. Return GC percentage. Okay, and then click the wrong button there. Sorry, I always do that. Then we're going to, let's have a couple of test cases here. And here is where you're going to see the power of this function, this whole concept of a function, because I can use it over and over again. Let's do ATGCGC. Okay, right, and then I'm going to use it, GC content. Right, so I've called my function, and now I'm going to throw in that ATGCGC. Okay, and we'll see what happens. There we go. So it's telling me that 66.666 recurring, that is 2/3, are G's or C, and that makes sense. So 1, 2, 3, 4 out of 6. So that is exactly 2/3. Let's try another one. Print GC of AATTGGCC. And again, no surprises. Content, and I'm going to throw that AATTGGCC. Okay, and then we'll run it again. There you go. This time 50% were G's or C's. 1, 2, 3, 4 out of 8. Correct. So that will work for any length of DNA sequence, and I'm satisfied that that would be good. I think what I might do is I might round it to 2 decimal places. How would I do that? This is an added bonus, right? I think I could do round sorry, round percentage to 2 decimal places. Let's see what happens if I do that. There we go. Because it was 50, it's just returned the float with 1 dp. That's fine. Okay, so you can style things like that as well if you want for text output. Right, that was question 2.